Perspective Class 4 Video 2. In this video we're going to talk about another type of linear distortion. This time we're going to talk about ST distortion. So let's move straight to the definition. The definition says that ST linear distortion is where you multiply the x coordinate by s and the y coordinate by t. So for every point on your figure you have some figure, and every point on your figure the x coordinate gets multiplied by s and the y coordinate gets multiplied by t. So the way you can write this algebraically is like this. Like xy gets mapped to sx, comma ty. And the stupid picture that you can draw, I guess, is like a smiley face, and then this smiley face becomes like I don't know, like flatter and wider. Maybe this is a 2/1/2 distortion, because all of the x coordinates got stretched by a factor of 2, and the y coordinate got shrunk. It got stretched by a factor of 1/2. Okay, so here's roughly the idea of what ST linear distortion is. There's a theorem I want to quickly mention, and it just says that ST linear distortion always sends lines to lines. Okay, and this is useful when you're trying to work out the ST linear distortion of some shapes, because this means if your shape is made up of a bunch of straight lines, you only need to work out the image of the corners, because you know that the lines must map to the lines. Okay, so I'll show you this in an example. Here's some diamond, and the question is just apply a 2/1/2 linear distortion. Okay, so I'll do this in a different color. So this point here, let's look at this point right here. This point is 2, 0, and that's going to get mapped to the point 2 times 2, 1/2 times 0, which is 4, 0, which is that point right there. Erase that because it's taking up too much room. This point here is the point 0, 2. This is going to get mapped to 2 times 0, 1/2 times 2, which is 0, 1, which is this point right here. Okay, and because I know that lines have to get mapped to lines, I know that this green line here, the one I'm like highlighting, has to get sent to this line here. Okay, easy as that. And now you just continue. Like if you do the same thing for this point, you'll see that this point ends up over here. So then you have this line. If you consider this point, you'll see that this point ends up here. So then you have this line and then this line. Okay, so this square diamond got squished and stretched to a very flat diamond. Okay, but it's still a diamond. This is the pink diamond is the image of the green diamond under the 2/1/2 linear distortion. The last thing I want to quickly mention is what happens to area. So this is an analogous theorem to what we were saying in the S distortion case. Okay, so in ST linear distortion, the area gets scaled by a factor of s times t. Okay, so remember in S distortion the area gets scaled by s squared. Well, now the area gets scaled by a factor of s times t. Okay, that's the end of this video.